Hi, I'm Mitch Gallagher. Welcome to the Sweetwater Minute. We have special guests with us here in the studio. Blackline Audio is here. We have Nate, the CEO, or King, as I like to refer to him, and Daniel, one of the design engineers. Appreciate you guys coming down from Chicago.
Yeah, thanks for having us.
Yeah, so you were doing the morning meeting, you were talking to the sales engineers, and we wanted to sit down and have a chat with you as well. We're very excited to have Blackline here, by the way. I think it's really awesome.
Yeah.
So tell us a little bit about the company. I know you mentioned that you've been around about 11 years now, right?
Correct, yeah. 11 years. We started out doing modifications in the early days and developed our own product line, and we're doing both still at this point. So we're 11 years this month.
Right.
Yeah.
So how does one get started modding gear? Do you just say, you know what, I'm going to pull that apart and see if I can do something with it?
Yeah, it's a lot of trial and error, I would say. Yeah, it's just getting your hands dirty, getting in there, pulling components out, trying new things, listening to the results, and then revising again and again and again. So yeah, there was no like manual for us to follow. It was just like, try this, see what happens. You make mistakes, along the way, but just figure out ways of, improving sound quality and go from there.
Right. So let's talk a little bit about that. You guys obviously have had a well-established reputation going back to day one of the improvements that your mods are making. And you talked about, the two of you talked about several specific things that go into really improving the sound quality of, for example, an audio interface. And a couple of the things that really stuck out to me is you talked about decoupling, number one, and you talked a lot about the power supply in general. Can you talk a little bit about those two factors and what else goes into actually improving, say, an audio interface?
Yeah, sure. Cleaning power up as much as possible is a big part of our modifications. So what we're doing is called decoupling, like you mentioned, and a lot of interface manufacturers do this, but they don't do it to a very great extent, or they don't do it at all. So what we do is we go in there and we're actually filtering the DC power rails in the analog stages and in the digital stages for the A to D and D to A converters. We're just filtering AC ripple out of those DC lines to make sure that that power, which happens to be the backbone of the entire system, like every active device is using that power supply, is as clean as possible so that you can get the best performance out of every active device as possible.
Right.
So we're really big on that. And it's really just giving analog treatment from, this concept's been around for decades. It's sort of analog treatment to the digital domain. People just think, a lot of times the misconception is that it's a recording interface, it's just zeros and ones, it doesn't matter, but it's actually a whole lot of analog design in there on the inputs and the outputs. So why not treat it as such? Right. That's kind of the concept there.
Right.
Converters in particular work a lot better when you're kind of hot rodding the stuff around them. So when power, we just have found is one of the biggest things we can do.
Right.
Those things, you just want them to operate at their highest level, and that's where we start. Yeah.
Right. Another topic you guys brought up that makes a big difference is clocking. Talk a little bit about that as well.
Yeah, so we found over the years that a lot of the internal word clocks that are installed in recording interfaces are almost an afterthought in the design process. So, you can get something to function. It doesn't mean it's functioning optimally. It works. And so the main specification we're looking at when we're talking about clocks is jitter. And specifically, we're looking at short-term jitter as opposed to like long-term drift. You'll see a lot of clock manufacturers talk about, it's stable for 2 years or whatever. But in audio, you got things firing thousands and thousands and thousands of times per second. So we're actually more interested in very short-term phase noise and what's going on in those characteristics. And we just found that, there's a lot of room for improvement on internal clock designs. And so in the early days, we started installing our own internal word clocks into interfaces that were much lower jitter than the word clocks that were in their stock. And then we ended up taking those internal designs and converting them to external units. That's our whole microclock series. So you can actually use it with a greater array of devices than what we actually just modify the internal clocks for.
Right.
Yeah.
And you currently have 3 clocks, or maybe it's 2 with a second version of the other one. Tell us about the 3 clocks that are available.
Yeah, so the Microclock Mark II is it's an oldie but goodie. We've had it on the market for a long time. It's $299 MAP, and it's just under 10 picoseconds of jitter. Very simple device. It has 3 BNC word clock outputs, and it's got a frequency selector. So you select your base frequency, 44.1 or 48, and then a multiplier to the right to get to the other sample rates. It goes up to 192.
Okay.
No display on it. Not even a power LED. It's very simple. You plug it in, it just starts putting out clock. That's been really popular in the live sound world, which we weren't even part of. We were in the studio scene, and it took off in the live sound world for reclocking digital consoles. The Microclock Mark III is drastically lower jitter than the Mark II, and it's got a bigger feature set. So it's under 2 picoseconds of jitter. It's got 6 BNC word clock outputs. It does 44.1 to 384, and it's got an actual display on it. It's got a dimmer for the display. You know, we put a lot more stuff into it. AES out on it, SPDIF out, optical SPDIF out on it. Then we have the XB, which basically comes from us modifying the standard and installing even more advanced components in there and getting better jitter specs as a result. So it's about 0.68 picoseconds. It's like roughly a third the jitter of the Microclock Mark III. It's insanely precise.
Right.
But functions exactly the same as the standard Mark III. So the Mark III is $799 MAP, and the XB is $999 MAP.
Right. If I understood the explanation you guys were giving, because you did a pretty deep dive into the way all this works, it's actually on the capture side that things are lining up, because the A to D and the D to A aren't necessarily communicating directly.
Right.
And so when there's error in that A to D stage, then the D to A is reproducing that error. Did I understand that correctly?
Yes. So if you're capturing something with the A to D is capturing that data according to the map is the analogy we use. It's given, that's the word clock. So the word clock is telling it when to actually take samples. If that word clock is off or there's error, there's going to be what's called quantization error. It's going to actually grab a sample at the wrong time. The D to A has no idea that the map, is incorrect.
Right.
So it just is starting to place those samples off of the wrong map. And so it gets reproduced on the D to A side as well.
All right.
And they're running at different times, your A to D and your D to A, so they're actually working off of different cycles, clock cycles as well. So jitter has a different impact on A to D than it does D to A. You can clean up the performance of a D to A converter by just reclocking it, and you can use the exact same recording session or program material, and it'll sound considerably different depending on the clock source of the D to A.
Right.
It's receiving a different roadmap.
Right.
So, yeah.
All right, very interesting. You don't think about that really fine detail that goes into actually making a digital system work.
Yeah, and a lot of what jitter translates to audibly is kind of phase issues in the high end especially. You don't know that it's going on until you hear a lower jitter source. It just cleans up the top end. And all of a sudden it feels like it affects a bottom end, like low end, because all of a sudden there's more room for everything else to just kind of breathe, and it fits in that sound stage better. And also there's more room for the bass. Right. So people actually think it's affecting the low end, and it's actually just a byproduct of cleaning up the high end from a better clock.
I see. Yeah, it's hard to put a lot of these kind of improvements into words, isn't it? Because first of all, it's subjective.
It is.
Second of all, it's a little bit difficult just to describe what's happening there.
Yeah.
When you hear it, you know what it is.
Yeah.
But talking about it is a little bit more challenging. Yeah. And as you guys also talked about, the specs don't always reveal how much of a change there is to what we're actually hearing.
Right.
It's not like a one-to-one. Like a better spec isn't a better performing thing, a better sounding thing. We like specs. We have specs for our products too, but we use listening to get to where the benchmark is, and then we use those specs as that benchmark.
Right.
So when we're choosing components, when we're making a decision on a design, like with the Mark III, Jesus was putting little bitty caps on the very end, and we tried a bunch of them to see how it made a difference. Just things like that. And when you think about a waveform being sampled at 44,000 or 100 samples, is that right?
Yep.
Did I get that number right? Yeah. Each one of those samples is dictated by where the clock is telling it to sit.
Sure.
So if sample 2000 is a little bit off, and then whatever percentage of those is off, that's where you start to hear your stereo image shrinks, the high end gets a little wonky, things like that.
Just to harp on specifications a little bit, so the parameters for when you're actually capturing specs matter a whole lot. So one very simple example would be you're talking about, let's just say the distortion on 2 different preamps. let's just say for simple numbers, these are terrible distortion figures, but let's say one preamp is 1% THD plus N, another one is 0.5% THD plus N. So which one's better? Well, the one with lower distortion, right? But what you don't know is that is at a 1 kilohertz sine wave, whereas the 1% THD plus N is full bandwidth, 20 hertz to 20K. A lot of manufacturers aren't telling you the parameters for the tests that they're running. This happens all the time in clocking too.
Sure.
In fact, there is no AES standard for measuring jitter. So there really isn't a way to compare apples to apples when you're talking jitter. And we've approached AES about this, and we didn't realize the burden of creating a standard is actually on the manufacturer. So you actually have to create a critical mass with other manufacturers surrounding an issue in order to make a standard, which we just can't take on right now.
Sure.
But that's a really important thing to understand about specifications. What are the parameters surrounding that spec? How did they take that measurement?
Right.
Will clue you into whether you're actually comparing the same thing or not.
Right.
Does that make sense?
Yeah, absolutely.
Okay.
Absolutely. It's very clear.
Yeah.
As you mentioned, Daniel, really what it matters is what it sounds like in the end, regardless of what
Absolutely.
the spec is.
Like spec, it's not a thing you avoid. It's just something. It's another tool,
Sure.
basically.
Sure.
Yeah.
Sure. You mentioned preamps, so let's transition over to you and talk about some of the things you were showing us this morning,
Sure.
which is the line of preamps that Black Lion makes.
Yeah. So our Auteur is a unique design to us. It's something that came out of years of looking under the hood of other people's gear, seeing what they did, and what we liked about it. So the Auteur has a really fast input stage, captures all the detail of your source. So all the information's there, and then we pump it through an EdCore output transformer to kind of beef it up. So it's got this hybrid, modern, vintage vibe going on, and it just sounds good anywhere you put it. It's hard to find somewhere that doesn't sound good.
Nice.
Yeah. So we also have our B12A, which is our tip of the hat to the API 312. It's not a clone, but it's our homage to that classic pre. We took the circuit, looked at it, decided what we liked and what we thought could be a little better, and it has a little more modern kind of punch to it.
Okay.
The high Z input sounds fantastic as well. I use it all the time at home, personally.
Right.
A Cinemag input transformer and an EdCore output transformer that we shot out against a bunch of other things. And the Cinemag is a name that we really stand behind, we really like. We also put that in our B173, which is a throwback to the 1073 pre. It's the same kind of thing. It's a little more modern version of that. It has that smooth, really robust sound that you'd expect from a 1073.
Right.
But a little more detail on the top end. So it's a little more versatile than maybe a classic 1073 pre would be. It has a Cinemag input transformer, EdCore output transformer.
Right.
And we also have a 500 series version of each of those pre's.
Right.
Yeah.
One of the interesting things you mentioned about the 500 series is that 500 series racks put out plus or minus 16 volts, but you actually operate those 500 series preamps at 24 volt rails. Now, a lot of people throw that out there, but what does that actually mean to the end user?
So the only one that runs on the 24 volt is the B173. 'Cause
Okay.
the circuit was designed on a 24 volt rail, and our half rack runs on a 24 volt rail. And you can derive 24 volts with a DC to DC converter, but what that entails is a switching circuit, and that adds a lot of noise to everything surrounding it,
Okay.
to the modules surrounding it in a box. So we spent a lot of time learning about that, designing a way to convert plus minus 16 to plus 24. And then we encased it in a little case, and it runs the unit exactly as it should without adding any noise or distortion to the circuit itself or any modules surrounding it. We had it working in the module itself, but the things surrounding it were picking up the noise. So it was just other hurdles to get over. But we managed to get there, and we can confidently run it on that plus 24 volt rail.
Right.
Yeah, so it's an exact copy of the half rack.
Right. That's very impressive.
Yeah, it took a long time.
Took a long
bet.
time.
It was a lot of his time, about a year.
Yeah, I learned a lot.
Of him banging
I
his
didn't know
head
I was
against
going to
that
learn about
issue.
it.
Yeah, I imagine. That's awesome. And what that translates to is increased headroom, correct? Dynamics and headroom?
The plus 24 volt? Yeah,
Right.
absolutely.
Right. So one of the things we're really excited about here is that Sweetwater is actually offering Black Lion mods
Right.
for
Yeah.
existing interfaces that customers may own. Tell us a little bit about that process.
Yeah, so you guys will be offering modifications on certain interfaces that you guys actually decided, and we can add more if you would like. But what that process entails is that a customer can actually call their Sweetwater sales engineer, say, hey, I'm interested in getting this mod done, and they can book it through you guys. It'll end up being shipped to us in Chicago. Our turnaround time is about 7 to 10 business days on the mod itself, and then we ship it back. And what the modification entails exactly depends on which mod is being booked, but in general, what we're doing is we're upgrading analog stage components such as op amps and signal path caps. And then on premium mods, we're also doing converter decoupling on the A to D and D to A converters, which is just filtering those power rails. Certain mods, we're also doing new internal word clocks. And other mods, we're adding a second linear power supply that actually separates the analog and digital stage rails and actually raises the analog stage rails in those mods. So you have increased headroom as well in your analog stages.
Right, so they're extensive mods. You're not just going in and changing a chip.
Right.
You're really going in there.
You're really going all out on them.
So when a customer sends in there, and this is really cool because if you have an existing interface that you already like and you just want to optimize that, make it sound even better, you can send it to you guys, get it back, and you basically got a new interface with all these new circuits and things in there.
Yeah,
Very cool that you can do that through Sweetwater. So we really appreciate that.
Yeah, we appreciate it as well. We're really excited about it.
Very excited.
That's just awesome. Awesome. Guys, thanks so much for coming down from Chicago.
Absolutely,
I know you made the trip through the snow actually today. It's just the snow. And glad to have you here. We're glad to have Black Line on board here at Sweetwater.
Great. Thank you so
you
much.
very
Thanks
much.
for having us. Appreciate it.
Nate,
Take care.
Daniel,
Thank you.
and thank you for joining me for the Sweetwater Minute. I'm Mitch Gallagher.